We will conduct a water pressure test to compare hoses with different silicone structures. First, we will test a braided reinforced hose. The hose did not change when a pressure of 1 megapascal was applied. When a pressure of 2 megapascals was applied, the connection part of the hose suddenly swelled and punctured. The hose punctured at low pressure because only the resin part of the hose stretched under water pressure and its reinforcement was lost. Next, we will test a special braided hose with the no torsion system. The hose did not change when a pressure of 1 megapascal was applied. The hose punctured when a pressure of about 3.8 megapascal was applied. Broken threads caused the puncture because the pressure exceeded the critical strength of the pressure-resistant reinforcing materials. The no torsion system completely ensures the pressure-resistant performance of the hose. In order to see the change to hoses used for chilled water in a factory in midsummer, we will make a comparison between an ordinary resin hose for industrial use and the Toyox drop hose with an insulating structure. It took about 40 minutes to conduct the experiment, but it will be fast-forwarded. To simulate the conditions of a summer, the temperature was set at about 40 degrees Celsius and the humidity was set at about 70%. Ten minutes have passed. There has been no change to the Toyox drop hose, which has been insulated. Water drops started to appear on the surface of the untreated hose due to the difference in temperature. The water drops became bigger and started dripping onto the floor. After 30 minutes, sufficient water drops had been formed to create a pool of water on the floor. There has been utterly no change to the Toyox drop hose and its joint cover. The Toyox drop hose can maintain a high cooling efficiency and a safe work environment. We would like to introduce the Toyox ring hose, a hose suitable for use at plant facilities, which will solve the problems of conventional hoses used at plant facilities. Conventional hoses that are reinforced with metal wires have the following problems. They are not recoverable once they are crushed. They lower efficiency because they reduce discharge quantities or stop the fluid flow. It is difficult to cut hoses reinforced with metal wires. To cut the metal wires, you need another tool, and you may cut your fingers on the tip of a metal wire. To dispose of hoses reinforced with metal wires, it is necessary to separate the metal from the resin parts. Because environmental conservation activities are being actively pursued, the increased cost of disposal has become a problem you cannot ignore. The Toyo ring hose will solve all these problems. Let's compare the differences between them using actual samples. First, we will conduct a test to compare the recoverability of crushed hoses. Let's find out whether deformed hoses can be restored. The hose reinforced with metal wires remains deformed, but the Toyo ring hose has been restored immediately to almost its original shape. The Toyo ring hose and its reinforcing materials are made only of plastics, so it is easy to cut and there is no need to separate anything for disposal. In addition, the Toyo ring hose is light, so its working efficiency is excellent. We will compare how the configurations of the Toyo silicon hose and the Toyo silicon S hose, which is reinforced with stainless steel coils, change during suction. The Toyo silicon hose has been completely crushed. The hose cannot be used to transport liquid. The configuration of the Toyo silicon S hose has not changed even under a pressure of 76 cm Hg in almost a vacuum condition. The Toyo silicon S hose can transport liquid stably even for suction. Let's try bending the Toyo silicon hose and the Toyo silicon S hose reinforced with stainless steel. The Toyo silicon hose was broken without being bent, but the Toyo silicon S hose did not break and stayed in a circular form. The discharge quantities of the Toyo silicon S hose are not reduced even when the hose is used in a cramped space. This is to compare how watering hoses twist when being unwound. Let's try unwinding an ordinary pressure-resistant braided hose and the Toyo Deliver hose, which is a special braided hose reinforced with the no torsion system. When a wound hose is unwound, the unwound part of the hose makes a smaller circle. When the ordinary hose was unwound, it rotated to eliminate smaller circles, but some circles were broken when their radii exceeded the minimum bending radius. Like the ordinary hose, the Toyo Deliver hose created smaller circles, but all the circles came loose when being unwound. So, the Toyo Deliver hose will not block fluid flows or retain the shape of the wound hose when unwound.